This video is for my pre-algebra classes. It is on lesson 28, scientific notation for large numbers. So ladies and gentlemen, I've got this number here written out for you. Just in case you haven't hit pause yet to count up how many zeros there are here. After my 725, we have a grand total of 20 zeros. 20 zeros. If we had to keep writing this number over and over and over, like let's say this was something that came up in science, and so part of our research required us to keep referring to this number, it's just impractical to keep writing such a huge number. So we've developed scientific notation as a way of shortening things like this. And it follows three pretty basic steps. So the first step is what's called the coefficient. A coefficient is something that's typically multiplied out in front of something else. In algebra, we usually see this when we have things like 5x. The 5 would be the coefficient. So here, our coefficient is going to be found when we rewrite the number by sliding the decimal so that there is only one whole number. We're using whole number as an adjective here, so it gets a hyphen. One whole number digit. So normally in a whole number, the decimal would be right here. But we're going to slide the decimal over. Now if I stopped right here, then 7, 2, and 5 would all be whole number digits. But we only want one whole number digit. So if I put the decimal here, the 7 and the 2 would both be whole number digits. So if I put the decimal here, then I will have just a single whole number digit. Now, ladies and gentlemen, this is the part that students sometimes have a little bit of trouble with here at the beginning, is some students will then say the coefficient is just 7. That's wrong. We are not chopping everything else off, we are sliding the decimal over. So if I just slide the decimal over, I'm still going to have that 2 and that 5, and technically I'm still going to have these 20 zeros. However, once we have a decimal here, we just don't need those zeros anymore. But we do still need the 2 and the 5. So my coefficient, 7.25. That's it. So one whole number digit. So you'll have something in the ones place, but nothing above that. You can have as many things as you need to in the decimal places, but only one whole number digit. All right, let's skip a couple lines here. Number 2 is the power of 10. When we move a decimal around, we move decimals by multiplying or dividing by powers of 10. So essentially what we just did is we divided this number by a gigantic power of 10. Because we moved that decimal a good number of times. So what we need to do is we need to counter that. We need to balance that out. So we are looking for what power of 10 is needed so that the coefficient will turn back into the original number. So if we think this through, our coefficient is 7.25. So first of all, I'm going to need to move the decimal 2 times just to get to the end of the coefficient. Just to get to the end of the coefficient. Now, once I get to the end of the coefficient, we need all these zeros back. So remember that there were 20 zeros here, so we need to now move the decimal far enough back here that we can put in 20 zeros. So how many places total does this need to move? Well, the 2 to get to the end, plus the 20 to get all my zeros back, equals 22 spaces. The decimal needs to move. So if it needs to move 22 spaces, then my power of 10 is 10 to the 22nd power. That 22nd power will move the decimal 22 times. Now, once I have those two, step 3 is very simple. We're going to write the product of the coefficient and the power of 10. Now, product means that we're writing this as a multiplication problem. So I'm going to slide that up here. So the coefficient, 7.25. Product means we're multiplying. And then power of 10 was 10 to the 22nd power. And that, ladies and gentlemen, is scientific notation. Now if we drop down several lines here, just a good number, let's rewrite this number. Oop, no comma there yet. So and then my 20 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So on the homework, this would be considered a yellow light problem. So I'm going to copy down my original number, equals, and then coefficient times power of 10. And that's what we would do on the homework. So we're going to practice this a few more times. So let's flip our paper over here. And we'll go with 910, comma, 000, comma, 000. So first of all, the coefficient, well, we know that the 9 is going to need to be my one whole number digit. So decimal, and then after that I'll have a 1, and then all of those zeros can just disappear. So my coefficient is 9.1. So now I need my power of 10. So times my power of 10. So if we think this through real quick here, we have 9.1 as the coefficient. We're going to need to move this one space to get to the end of the coefficient, and then I'm going to need 1, 2, 3, 4, 5, 6, 7 zeros. So I need to scoot this over so I have room for 7 zeros. So add those together, my power of 10 will be 8. So 9.1 times 10 to the power of 8. Next example, 8, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. So in this case, I'm going to go ahead and write my coefficient, which will just be the 8 this time. So my 8 will be my one whole number digit. All the others are zeros, they're just going to disappear. Instead of writing out the red this time, I'm just going to go ahead and think it through. So being just a single digit, there's no need to move it over to the end of the coefficient. The decimal would already be at the end of the coefficient. So all I need now is my 3, 6, 9, 12 zeros. 8 times 10 to the 12th power. Next example, 602, comma 0, 0, 0, 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 comma 0, 0, 0. Now this number here actually is a special number, particularly gets used in science and chemistry. This is what's known as 1 mole. 1 mole. And what's special about a mole is that if you take any element, and if you have a mole of that element, so that many atoms of that element, then you have its atomic mass in grams. So for example, if you had something that had an atomic mass of, let's say, 53, well, if you had this many atoms of that element, it would be 53 grams of that element. So this actually does show up in chemistry a bit, but we don't want to write it like that. You will pretty much never actually see it written like that in chemistry because it's just too long. So instead we write it in scientific notation. So 6 being the largest place value here, that's going to be my single whole number digit. I will need the 0 here to make sure that the 2 stays in the proper place. So the 2 is not right next to the 6. We do need this as kind of a spacer, a placeholder. The rest of those zeros, though, after the 2 can all go away. So 6.02 is my coefficient. Now times my power of 10. So I will need to move this 2 times to get to the end of the coefficient. And then I'll need 3, 6, 9, 12, 15, 18, 21 zeros. So 2 to get to the end of that, plus 21 zeros, 6.02 times 10 to the 23rd power. This is why October 23rd, October 23rd is sometimes called Mole Day, after 1 mole. Well, ladies and gentlemen, we're going to switch gears now, and we're going to take a look at how to go from scientific notation back to standard notation. So standard just means normal. And we'll start with 4.75 times 10 to the 13th power. And so we kind of think about this like we did up here, but we're going to go backwards because this time I know the power of 10 and I want to figure out how many zeros we're going to have. So 4.75, it would take 2 to get to the end of the coefficient. And then if I have 13 though, then 2 plus what gives me that 13. So I have 11 more spaces I can move with that 13. So that means I'm going to have 4, 7, 5, and then with 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your commas in every 3 digits, and there's my number. So if I look at the place groups, The first group here is the base group or the ones group. Then I have the thousands. These are the millions. These are the billions. These are the trillions. So this is 47 trillion, 500 billion. Next up, let's do 3.9 times 10 to the 17th power. So 3.9, it's only going to take one of those 17 tens to get me to the end of my coefficient, which means I have 16 more to total up to that 17. So one of them will get used just to get to the end of the 3.9, and then 16 more will turn into zeros. So 3, 9, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros. Put your commas in every 3 digits. Ooh, that's a much bigger number than the last one, wasn't it? So again, if I look at my groups, this is the ones or the base group, then the thousands group, the millions group, billions group, trillions group, quadrillions group. This is 390 quadrillion. All right, next up, I have 6.125 times 10 to the 9th power. So once again, imagine my coefficient here. So I get to move the decimal 9 times. It's going to take 3 to get to the end of the coefficient, and so that means I've got 6 more that will turn into zeros, because 3 plus 6 is 9. So 6, 1, 2, 5, followed by 6 zeros. 1, 2, 3, 4, 5, 6. Put your commas in. There's my number. So I'm going to go back here. I'm going to circle my answers. And that is how we change scientific notation back into standard form. Last skill we're going to talk about here in this lesson, draw another little dashed line there, is multiplying numbers in scientific notation. We consider the coefficient and the power of 10 to be one number. This is one number just written in a different format. So when I multiply them, often you will see them written in parentheses. So when I write this, this is just a way of grouping this to say, hey, 8 times 10 to the 12th power really is 8 trillion. And I'm going to multiply this then by 6 times 10 to the 7th power. Now, in the end, this really is all multiplication. These are being multiplied, these are being multiplied, and between them, they're being multiplied. Parentheses next to parentheses means multiplication. So the short of this is multiply your coefficients, multiply your powers of 10. So coefficients, 8 times 6 is 48. If you have 12 tens times 7 more tens, that's going to mean you have a total of 19 tens that we're multiplying by. So remember, when we multiply powers, we add the exponents. So that 12 exponent plus that 7 exponent makes a 19 exponent. Now, ladies and gentlemen, if we start with scientific notation, we want to end with scientific notation. And remember, the rule with scientific notation is you can only have one whole number digit. Well, a 48 has 2 whole number digits. So while this is a good stepping stone, it is not an acceptable final answer. So what we've got to do here is we've got to do a little bit of thinking. My 48 here if I were to reimagine this as scientific notation, just it, well, my coefficient would be 4.8. 4.8. And then my power of 10, well, how many decimal places would we need to move to go back to 48? Well, just one. And then we're multiplying this with 10 to the 19th power. So if we think that through, we should see then that 4.8 is going to be my coefficient, and then the 10 to the first power that would come from this scientific notation will combine with 10 to the 19th power to make 10 to the 20th power. So 8 times 10 to the 12th power times 6 times 10 to the 7th power equals 4.8 times 10 to the 20th power. We'll do another one like this. 7 times 10 to the 8th power. 5 times 10 to the 9th power. Again, multiply your coefficients, multiply your powers to 10. So my coefficients are 7 and 5. 7 times 5 is 35. My powers of 10 are 10 to the 8th and 10 to the 9th. So when we multiply powers, we add the exponents. So 8 plus 9 is 17. Again, good as a stepping stone, not acceptable as a final answer. So now I want to reimagine 35 as its own scientific notation. So we'd scoot that decimal over to make it 3.5, but then times 10 to the first power would just move it once to go back to 35. We are multiplying this with 10 to the 17th power, so now if we put everything together, my coefficient is 3.5 times 10 to the 1 plus 17 is 18th power. And we'll finish this off with just one more. 2 times 10 to the 12th power times 4 times 10 to the 6th power. So this time, 2 times 4 is 8. 10 to the 12th power times 10 to the 6th power, well, 12 plus 6 is 18. Now this time I only have one whole number digit, which is just fine. So I do not have to take that extra step. I can stop right there. So once again, ladies and gentlemen, when you are multiplying things in scientific notation, word of caution, make sure that if it has more than one whole number digit, that you take the extra step to simplify it. And that, ladies and gentlemen, is the end of this lesson.